continuing on from the previous example, we're going to take a look at the intended workflow for the RBD fracture and how all these nodes are supposed to improve the workflow. Now, I wanted to talk about a concept or a main concept in Houdini that is very, very important, and something that I really like and enjoy, and a lot of people do, is the fact that as a terminology, Houdini has this concept where each node does a specific thing. You have an input and then you have an output. Now, the more that node starts doing, the more feature the node does, the harder it becomes to use it. So for example, for me, whenever I design something, I try to break it into a lot of small steps that I can stitch them together. So for example, if I had a fracture workflow, I would create the node that creates the fracture, and then if I need to add details to that, I'll create a node that adds details to that. If I need to add edge displacement, I will have a node that does the edge displacement separately. And then if I need constraints, I will have a separate node that has everything related to the constraints and things like that. Now, something new that has been introduced in Houdini 17, Houdini 16 to be exact, is the concept of having multiple inputs and multiple outputs. This works great for various workflows, and the first thing that Side Effects started testing this with is the hair grooming. And in that scenario, it makes a lot of sense to have, for example, the geometry of the characters or anything you're going to emit the hair from. You're going to have a second input for the guide curves, and you're going to have a third input with some kind of paint or something like that. So all these three things make sense to go in together. Okay, but in some other scenarios, I don't believe that this is to be true for destruction, for example, and this is my own personal opinion. If you find that this workflow works that I'm gonna demo works great for you, please don't hesitate to use it. But in my opinion, this workflow that requires multiple inputs and generates multiple outputs is not suited for destruction, because for me, the first requirement, for example, that this needs is to have all the geometry packed together, grouped together. So, and in this case, I have to have a merge node that concatenates everything. This is something I don't want to do. Merging the data together is not a great thing to have, especially if you have a lot of complex shapes. First, the process of the merge node is going to be slow. If you have any distinguishing attributes in any of the mesh, they have to all map together or match together. And then once you merge this data, let's say you have groups or you have colors or you have extra attributes or anything like that, it's gonna merge all that together, and this is going to make it really hard to debug, especially for destructions. Now, they are also testing this workflow with Vellum, and I think for Vellum it makes a lot of sense as well, even though I still like to have extra control over certain things. I think it's a great approach to use it, and this actually is something that changes Houdini quite a bit, the way it works. And I've been teaching Houdini for quite some time, and I know that the existing concepts already can be really daunting for new users to digest, and sometimes for even intermediate level users. This concept of multiple inputs and multiple outputs is really confusing even for senior people. And one very important aspect that I like to keep in my setups is simplicity. I like to have everything organized and separated so that when I look at the graph, I can easily understand what I've been doing. We're going to build a simple RBD fracture for these three pieces. I'm going to show you what, in my opinion, is going to be a terrible file to look into after 4 weeks or 2 months, and it's going to be really hard even for students to understand how all this works. Now, I'm not saying that this is not a potential workflow for RBD, to simplify the RBD. I just don't think that is what I want to use for a complex setup or a high-res building destruction or anything like that. So let's take a look. We have, if we right click, we have these guys. I have RBD cluster, constraint property, interior details, and the fracture, pack, paint, and pack. The primary one is this, and the data that you need to pass into this node has to have specific information. One of the features that we will get with this is the ability to create constraint based on different materials. Okay, so let's say we have wood, glass, and concrete. We can say, okay, the wood, I want to know or have a constraint that connects the wood to the concrete, and then I want to have a constraint that connects the wood to the glass. This node with a little bit of setup can generate that, but it's not something that we can do before with Houdini. We can simply say, okay, this guy is named wood, this is glass, and this is concrete. Create a constraint network over everything, and then if the name of the constraint is the same, we delete that information. If the name of the material, we create a constraint that inherits this information, and then if the name between the 2 points is different, we keep that. If it's between two nodes that have the same material attribute or type attribute, we delete them. This way we're going to get something that connects these two guys, and it's going to connect these two guys. So it's not something I would be happy to do a lot of preparation for it, especially that this is a very simple setup. So the first thing we need to do for this to work, I have the concrete here, I have the wood, and for the wood, it's actually, these guys are separate. So let me do an exploded view so you guys can see it. So the wood border is actually made of 4 different pieces. Okay. So what we need to do, this is the concrete, the wood, and the glass. Okay, we need to first create a name attribute. So we have to name these guys, even though this is not fractured. Even though this is not fractured or anything, we have to name them for the system to work. So using an assemble node, I call this glass. I'm going to call this wood for the wood, and then concrete. I'm also going to create groups for each of the materials. So wood, concrete, and glass. Okay, and then I merge everything together. Now this is where things can get a bit tricky. Let's say we have a custom attribute called with these guys, and I'm gonna call it it's a rest attribute, for example. And let's say I have custom normal. It's just unique for these guys, that is equal position as well. And then I have a float. Bar equal 100. Okay, now these attributes are just unique for these guys. When I middle click here, I know that this is where they're coming from, but if I look here, you see the attribute is actually it's showing us as if the attribute exists on all the geo, and we don't know that that's the case. Okay, if we look at the merge node, it will show us that, it will tell us that, hey, you have a mismatch attribute, but that's fine. It's not a problem if we know that that's happening. But later on, or the fact that I'm forced to do this is not a great thing, to be honest. So let's say we import this data somewhere, okay, and then if I look at it now, I don't see that error anymore. And I would assume that custom normal is on all this mesh, same for V, and same for rest and all the other attributes. So that's something I'm not very excited about. Okay, so then I would feed this into the RBD fracture material, and the idea is we're going to use those groups to tell this node to only work for certain pieces. Okay, so the first one is we're going to do the glass. So here I'm going to say glass star, and I'm going to use the glass material type, and this is actually a great feature. I really like the patterns that we get here, and there is no harm in using the RBD material fracture to fracture the pieces for us. Now, because these three objects are separate right now, it's treating them as a unique piece, and you can see already that the fracture center is here. What we need to do for this node to treat each one of these guys individually is to turn on fracture per piece, and this is going to basically loop over each one of the guys based on an attribute that we specify. Right now the name is the attribute is called name, and that's what's going to be used. Okay, now first thing, as you can see, we're getting some cool patterns. We can increase the scatter points, which will generate more impact points, and then we can control how many cracks radially and how many cracks along how many of these repetitions there is. We can also turn on and off the edge details. Okay, but what I'm not very happy about is the result of the fracturing. This is a very simple thin object, and as you can see on the back, it's not giving us what we want, and I actually don't have a way to fix this. It could be that no, I know why, sorry. Okay, so this piece, the glass didn't have back faces. Okay, so great, it's a big improvement. So okay, the fracture works, nothing to blame here. And let's turn on the edge again, and we're getting the patterns. We can increase the number of points, and it's just a matter of playing with the settings here. Now we can continue doing this. We're going to use a different node for the RBD, for the wood, and for the concrete. But something that a feature from this workflow is to get the connection, the constraint connection between the pieces. And the way that works is we have to do some preparation for this. Now, what I'm going to do is I'm going to isolate the concrete and the wood. Okay, and then I'm going to isolate basically the things that I would want them to be together. And this is the glass and the wood. And I'm going to use a connect adjacent pieces node and set it to surface points. Okay, so this is the connection. It's not fracture or anything, just a way for this node to understand the relationship. I'm gonna call this wood glass, and it's very important to do that too. And then we're gonna do the same thing here, and this is for the wood and concrete. And we do connect adjacent, and this is concrete, wood. Let's merge these guys together, and now we have this information we're going to pass into this constraint geometry node. Okay, cool. So as I was saying, in Houdini we're used to have a single input and a single output. Well, there are scenarios where there's multiple outputs, but it's not exactly this. So we have two inputs and we're getting multiple outputs. Now, a main thing in Houdini is when you look at the data here, you look at the spreadsheet, and then you want to know what the next node does. You simply look over here, select the node, and then open the spreadsheet and compare them. But this is not the case anymore. We have much more data coming out of this node that wasn't here before. So we now have to look at each one of these guys individually. So this is the constraint network, and this is the proxy mesh. Okay, so let's take a look at the constraint network, and if we middle click, you see we have different attributes, and this is not something that we saw when we did a middle click here. Okay, this data is not visible. So we have multiple groups, we have attribute names and stuff like that, and I'm going to go under the constraint tab and name this glue glass. So the constraint name has a unique value. And see, I have the habit of middle clicking, expecting to see something to change here, but that's not the case. So the constraint name should be set now correctly. Let's take a look. And it's a glue glass attribute. Now we need to continue adding more nodes for this to work properly. So one more RBD fracture node. And then I'm going to fracture the wood now. And I'm going to use the wood pattern. Now what this does is it's going to analyze the bounding box of the geometry. That's why I had the wood, the windows border separated into 4 pieces, so that this node works properly. It can analyze the bounding box and figure out the exact orientation of the piece. And this way it's going to create the splinters aligned properly and the grains for the wood pattern. Now it's going through the fracture. I'm going to hit cancel. And I'm going to say fracture per piece, so it loops over each one of these guys, okay, individually. And then I'm going to, let's see, let's turn off clustering and let's lower the density to 5 and the detail size to 0.25. And let's take a look. So it's going now. It's still going. And I want you guys to see this happening live. I don't want to skip any of this because I honestly find this workflow to be terribly slow when it comes to fracturing. I mean, we're just fracturing these guys here, and there we go. That's the result. So with the wood so far, I couldn't get it to work properly, and I'm not so sure why. But I mean, the fracture node, I didn't get it to work especially with more complex geo, it was not working as I expected. And for this guy, it's really simple. So what I'm going to do, I'll give you guys the scene. Please continue exploring these guys. Maybe you will find a better setting that works. But I know that I can easily fracture this in a wood-like pattern without any issues, and it will take probably 1 second for it to compute everything. So what I'm going to do is I'm going to switch this to concrete, and for now we're going to treat wood as concrete because it's more stable. Okay, so let's do this, and I only need 1 layer of fracturing. And this name, this is something I previously mentioned, and I'll clarify here. When I first tested the RBD fracture material, they didn't have this ID. Okay, they didn't have this attribute. But now with this, we can identify the constraint network for each iteration. So if we do, the first one is going to have a specific glue constraint, the second one is going to have a second glue constraint, and so on and so forth. So this is actually a great addition, but it doesn't convince me to use these nodes yet. So let's continue. So I'm going to call this wood fracture 1. Okay, so that's the wood fracturing. And then the last node I'm going to use is another RBD fracture. And I'm going to leave it to have 2 levels here. Okay, so that's working. And now we finished pretty much fracturing everything. and I'm going to look at the constraint networks. So this is everything that was generated by the graph, by the nodes. And as you can see, we're streaming in every time the constraint network. And if we middle click, we're gonna see something, these groups, wood class, and we should see concrete wood, okay, and then we should see wood glass as well, but for some reason it doesn't have enough it doesn't have anything here, so something happened along the way. Let's increase the number of pieces here, maybe that's gonna help. Yeah, I don't see a connection there, but let me isolate these guys. So the first thing is we have a constraint network for anything that is concrete, okay, and this one is empty, so let's take a look at the fracture one. Okay, so this guy, the node, has two constraint network for each level, one called this name and the second one is called this name. So this is one and this is the second one. And then what do we have? We have a concrete wood, and this is the one that these nodes generated. It connects the wood to the concrete. And then for the, let's see, we have the wood fracture. This is the constraint for the wood pieces. And then we have the glass centric, and this is very cool. And then the glass radial. Okay, so these are all the constraint network that we've got for free. But honestly, I personally think that these nodes, as you guys saw, I mean, we're not doing anything crazy yet. Just simple geometry here, and it feels really slow for me compared to what I've used to use before. And then this feature of having connection in between the materials, I mean, there's nothing new here. There's nothing that we couldn't do before, okay. And then the main thing that I'm not going to be pushing for these guys is that I want you guys to fully understand Houdini, and by showing you how we can create a recursive fracturing system, you're gonna learn a lot more about how Houdini works and stuff like that, and how we can create our own high-res geometry. If you find these nodes suitable and you like what the outcome and setup is, please use them. If you like the workflow that we're going to be talking about in the next few weeks, please use that or whatever makes you comfortable. Now, I don't deny that these nodes have a cool pattern for the glass and for the wood, especially if it works, but again, there is nothing that we couldn't do before here. And if we didn't do this, okay, what we would have done instead is this. Okay, so let me delete those guys, so less node, and we would use a Voronoi fracture and scatter some points, and we can always create an OTL out of this. Okay, it doesn't have to be always this graph. We can create an OTL that that represents all the features that we need. A VDB volume with noise. We can scatter points, we can paint, we can do all this. So I would fracture this way, and then this guy for the wood, and I don't need this, and then this, and I have all my data is there. And then I would merge, or I would use, so for this I would call it glass here, so the name is not the same, and then wood, concrete, and we merge all these guys, assemble them, and I just need the name, and then I would do connect adjacent pieces, and that's a constraint for everything. And then this goes into RBD and then the constraint network. That's it. And no need for names. So out RBD. And then out CST. That's it. That's the setup here. And I think it's very flexible. I still personally prefer this workflow, especially with high-res meshes where I can deal with each individual piece separately. With this, you can see already by just looking at this, it takes time for it to cook. And then if the other thing is we're getting these constraint network every time. I don't want that. I don't want to be paying for the overhead of creating constraint network every time I change a slider. Even if we turn it off here, it doesn't turn off the constraint. It just turns off the naming of the constraints. Okay? And I don't want to be paying for that every time, as well as the fact that the Boolean fracturing is not stable yet. So this is the overall overview of the nodes. The other guy that is that I like is the RBD constraint node. So what this does is it creates attributes. That's pretty much it. Without this, we would do this as constraint name equal glue, and then as constraint type equal all. And if we need strength, for example, we would set strength, and these are the main attributes, okay, for the constraint network. Yeah, see it, we can view it. I have to use a null, and then impulse, health, and all these attributes, they're not, we will only use them when we have to. And again, I'm not this is just an OTL. There is nothing crazy about this that would force me to use this node or anything like that. So the takeaway, we're not going to be relying on these guys except if we need glass fracturing and if it works in that case, and pretty much everything else we're going to be doing from scratch. So thank you guys for watching, and see you in a bit.